Welcome to the students new session. In the last lecture we have discussed about limit and their approaches, and how we can perceive the idea of a limit. So after having an idea of the limit, the next stage is what? How we can calculate the limit of the various kinds of function. So in this lecture we will discuss the various methods to find out the limit of the various kinds of function. As far as the methods for finding out the limit of a function are concerned, there are four methods which we can use or which we will use to find out the limit of the various kinds of functions. Method 1 is known as the direct substitution method. So direct substitution, you know the meaning of what direct substitution is. If any object is being replaced by any new one, is known as the direct substitution. You have seen when you are watching the cricket match, a player is being substituted by any other one. So the same thing will happen here, right? So the in direct substitution method, what we did, we substitute the value of the point in the given expression. If we get a finite number, then that number will be considered as a limit of the given function, right? And whatever value of x is approaching, we will substitute that value of x directly in the given function or in place of x, and then simplify it. If we are getting a finite number means 0 is also a finite number. If you are getting 0, then it is a number and 0 will be considered as a limit. So by putting the value of x directly in the given function whose limit you want to calculate, if you are getting a finite number, that number will be considered as a limit. So let us take an example. For example, evaluate the limit of this function. Limit x tends to 2, 3x square plus 5x plus 17, right? This is question number 1, right? I have taken 3 different questions to make the things clear before you how we can use the direct substitution method. So take example 1. So here limit is approaching towards 2. That is, what is the value of the function 3x square plus 5x plus 17 if x will approach towards 2. This is what we want to calculate. So the direct substitution method simply says what? If x tends to 2 or x approaches to 2, then we will put the value of x is equals to 2 directly in the given function. Are you getting the point? We will put the value of x is equals to 2 directly in the given function, because in the last lecture we have seen whatever we are getting by direct substitution of the variable or whatever we are getting by limiting case, in both the cases the value of the function comes out to be same, right? So in direct substitution method, look at this example. X tends to 2, 3x square plus 5x plus 17. Now replace x by 2 simply. What will happen? See, 3 will remain as it is. This is x square. So x square means square of 2. So 3 into 2 square is this, plus 5 will remain as it is. In place of x put 2. So this is 5 into 2 plus 17. Simplify it. 17 plus 10 plus 4 into 3, 12. Some add up all these things, you will get 39. So 39 is called the limit of the given function. So what does it mean actually? It means when x will move towards 2, then this function will move towards 39. Yani if x will tends to 2, then the function 3x square plus 5x plus 17 will move towards 39. And that is why this 39 is called the limit of the given function. Take example 2. This is limit x tends to 4 here, x cube minus 64 divided by x upon 5. See, x cube minus 64, x tends to 4, x cube minus 64 divided by x plus 5. So x tends to 4. We will put simply x is equals to 4. in the given function. So 4 into 4 into 4, that is 4 power 3 minus 64. Here in denominator 4 plus 5 is 9. So 4 into 4 into 4, 64. 64 minus 64, 0. 0.9, that is 0. So whenever x will approach towards 4, the function will exactly equals to approach towards 0. So 0 is called its limit, right? Clear? Now take the question number 3. Limit x tends to 0, root square root of 3 plus x plus the square root of 3 minus x divided by 3 plus x. So this function numerator contains square root, right? Now first we will try what will happen if we put x equals to 0 in the given function. See, root 3 plus x, replace x by 0 or put x is equals to 0 simply in this function. So you will get here root 3 plus 0 plus root 3 minus 0. Here in denominator we will get 3 plus 0. So root 3, what is left here? We will get here root 3 plus root 3 divided by 3 plus 0, right? And then root 3 plus root 3 you will get here 2 root 3 divided by 3. This is the required limit of the given function. So this is actually all about the method of direct substitution. So what you have perceived, what you have concluded from these 3 examples, that is what the first method to find out the limit of any function is the direct substitution method. And in direct substitution method, we will directly put the value of x in the given function and simplify it. We must get a finite number, only then that will be considered as a limit, right? So come to the method 2. The second method is known as factorization method. You know, you all have studied the method of factorization at your 8th or 9th standard. There are many polynomials, there are many equations even whose factors you all have calculated. So you must recall all those methods. I am not able to explain the method of factorization here due to lack of time. But the process or the approach what you did at your earlier classes will remain as it is. So this method is what factorization method. The first thing is what, under what condition the factorization method works. This is very important. Let us take the case, the factorization method to find out the limit of any function is applicable only when the function is of the form of fx upon gx. This means if the function is rational. Rational means a function which contains numerator as well as denominator. If the function is of not this type, we cannot use the method of factorization. Are you getting the point? Number 1, the method of factorization works only if the function contains a numerator and denominator. Otherwise, we cannot use the method of factorization. At most, the numerator fx may be equals to 1, then your function will be 1 upon gx. Again, we are having here numerator, that is 1. After having the function of the type of a numerator and denominator, what we did next? We have already studied method 1. So what we will do first? First, we will use the method of direct substitution, right? The method of direct substitution means put the value of x directly in the given function as we did in case of method 1, okay? And then simplify it. What you will get? Either you will get a finite number. If you are getting a finite number, your solution has been attained, is it? If you are getting any one of these two cases, either 0 upon 0 or infinity upon infinity, then the method of direct substitution fails, because 0 upon 0 and infinity upon infinity both are undefined quantities in mathematics. They cannot be considered as a finite number. Clear? So what is the idea? The idea is this: whenever the function is of the type of numerator upon denominator, what we will do first use the method of direct substitution, means put the value of x directly in the given function and then simplify it. There are two ways. Either you will get a finite number. If you are getting a finite number, that finite number will be considered as a limit of the given function. Case 2, if you are getting either of these two conditions, that is 0 upon 0 or infinity upon infinity, these two numbers are undefined mathematically. So naturally, the method of direct substitution fails in this condition. And if method 1 fails, only then we will opt for another method. And that is known as the method of factorization. Clear? I am repeating once again, when the method of direct substitution fails, only then we will use the method of factorization. Right? What is the process or what is the approach of the method of factorization? Look at here. The function is given in the form of numerator upon denominator. I am explaining this step. Whatever function is given to you, fx upon gx, first use method of direct substitution, simplify it. If you are getting a finite number, that is the limit of the given function. Clear? Anyhow, after putting the value of x in the given function, if you are getting either 0 upon 0 or infinity upon infinity, then the method 1 fails. Then method of factorization came into play. What method of factorization says? We will find out the factors of numerator and then we will find out the factors of the denominator. Some factors in numerator and denominator will be common. These factors will be cancelled out. What else left? We will again use the method of direct substitution to find out its limit. Clear? Let me explain once more. Whenever a function is given to you that is of the type of fx upon gx, first use the method of direct substitution. If you are getting a finite number, your solution is achieved. If you are getting 0 upon 0 or infinity upon infinity, then the method 1 fails. Method 2, that is factorization method, came into play. And what is the process of the factorization method? Find out the factors of numerator as well as denominator both. Right? When you will find out the factors of both, some factors will be common. They will be cancelled out. After cancelling out the factors, what else left? Again use the method of direct substitution, simplify it. What else number you are getting, that will be considered as a limit of the given function. So what does it mean? Finally, whatever method you are using, the limit is always obtained by using the method of direct substitution. Clear? Let us take an example. For example, limit x tends to 2, x square minus 5x plus 6 divided by x square minus 4. So here your NR numerator is x square minus 5x plus 6, and your denominator is x square minus 4. The function is of the type of fx upon gx. Let us take the case. X square minus 5x plus 6, x is tending to 2. So first what we will do, we will use the method of direct substitution. That is, put x is equals to 2 in the given function and see what happens. When we will put x is equals to 2, so we are getting the form 0 upon 0, because 2 square 4 minus 10 6 minus 6 plus 6 we will get 0, and here also 4 minus 4 we will get 0. So after putting x is equals to 2, we are getting 0 upon 0, any indeterminate form we are getting, right? So if we are getting indeterminate form, it means the method of direct substitution fails. Now we will opt the method of factorization. And you know, for factorization method, your numerator is x square minus 5x plus 6. Find out the factors of x square minus 5x plus 6, and your denominator is x square minus 4. Find out the factors of x square minus 4 and then see what happens. So x square minus 5x plus 6 is equals to 0. For example, this is an equation. How we will find out the factors? Do you know the method? This is 6, find out the two factors of 6 whose sum is minus 5. That is, look at here, minus 3 into minus 2, you will get here 6. Clear? And minus 3 minus 2, you will get here minus 5. So, this equation x square minus 5x plus 6 is equals to 0. This can be written as x square minus 3x minus 2x plus 6 is equals to 0. Take x common, you will get here x minus 3. Take minus 2 common, you will get here x minus 3. This is x minus 2 and x minus 3, right? So, x minus 2, x minus 3, they are the factors of the numerator. But here in denominator, it's very easy. This is x square minus 4. You know the formula of a square minus b square. This is what? A plus b and a minus b. So, what you will get here? X square minus 4, this is equals to x minus 2 and x plus 2, right? Now, x minus 2 and x minus 2 will be cancelled out. What is left? Limit x tends to 2, x minus 3 divided by x plus 2. This is what we left after cancelling out the common factors. Now, here in this case, we will again use the method of direct substitution, that is, we will put x is equals to 2. So, put x is equals to 2, 2 minus 3 upon 2 plus 2, that is minus 1 upon 4 is the required limit. Clear? I hope you will be very clear in this matter. Let us take another example. Take this one. This is a limit x tends to 2, x cube minus 6x square plus 11x minus 6 divided by x square minus 6x plus 8. So, here numerator contains an equation or a polynomial of degree 3 and denominator contains a polynomial of degree 2. And you know from your 9th or 8th standard how we can find out the factors of any polynomial whose degree is 3. So, its degree is 3, it will certainly contain 3 factors, right? In denominator the degree is 2, it will certainly contains 2 factors. So, we will start the solution. The first approach is what? Put x is equals to 2 in numerator as well as denominator, we will get 0 upon 0.4. You can check yourself, right? It means the method 1 fails. We cannot use the method of direct substitution because we are getting 0 upon 0. So, the next stage is what? We will find out the factors of the numerator, this, and then the factors of the denominator. So, I cannot explain the factors of x cube minus x square plus 11x minus 6 here because I have a bounded or limited time. Factors of a polynomial of degree 3 can be achieved by first find out its first factor by using the method of hit and try. You will get the first factor. After getting that first factor, divide the remaining equation by that factor, you will get the remaining 2 factors. So, the factors of this are x minus 1, x minus 2 and x minus 3, and here x square minus 6x plus 8, the same as we did in earlier. The factors of this is, when you find out the factors of 8 whose sum is minus 6, right. So, this is what? X minus 2 and x minus 4. What is common? This x minus 2 is common. What is left? X minus 1 and x minus 3 upon x minus 4. So, here we will use again the method of direct substitution, means put x is equals to 2. So, this is 2 minus 1, 2 minus 3, simplify it, you will get 1 upon 2 as its limit. So, 1 upon 2 is the required limit of the given function, right. The similar way you can approach for case 3. Case 3 is what? Limit x tends to 3, x upon x minus 3 minus 9 upon x square minus 3x. So, this is how look at the solution of this question. See, limit x tends to 3 remains as it is. This is the question. Take LCM of these two, right. Here we have taken LCM. The LCM of this is x minus 3. And in numerator you will get x square minus 9 because x minus 3 will be cancelled out, x into x we will get here x square. X square minus 9 is what? x square minus 9 by the formula of a plus b, a minus b, you will get its factor x minus 3 and x plus 3. In dr we have x minus 3, so this will be cancelled out, x minus 3 cancels out, what is left? X plus 3 divided by x. Now again use the method of direct substitution, means put x is equals to 3, so 3 plus 3 is 6 divided by 3, that is 2 is the required limit. So this is how you can also use the method of direct substitution to find out the limit of the various kinds of function. Now the third approach is what? Rationalization method. So rationalization method, to understand the rationalization method, first you know the process of rationalization. You know, whenever a function is of the type of fx upon gx, right? The condition for the rationalization method is same. Your function should contain a numerator as well as denominator. Otherwise, you cannot use this method. But the difference between factorization and rationalization method is what? In factorization method, we were having the function of the type of this, but in this case, we will have the either this or this, fx divided by root gx. What does it mean? It means the function should be of the type of numerator and denominator, but at least numerator or denominator must contain a square root. Only then we can use the method of rationalization, right? Clear? The basic difference between factorization method and rationalization method is, in case of the rationalization method, either numerator or denominator must contain a square root. Only then we can use the method of rationalization, otherwise we cannot use the method of rationalization. Rationalization is what? Rationalization is simply known as the process of removal of the square root from the given function. So naturally, if nr or dr will contain a square root, so our approach is what? How we can remove this square root if nr contains, and then this square root if dr contains. So the removal of the square root from a given function simply known as method of rationalization. What is the approach? Look at this method. We will use the same approach here whenever a function is given to you either of the form this or the form this. The first step is what? Use the method of direct substitution first. If you are getting a finite number, your solution has been achieved. If not, if you are getting either this or this, as we did in case of last method, if you are getting 0 upon 0 or infinity upon infinity, means indeterminate form, then the method of the direct substitution fails. So we will use the method of rationalization. So what are the basic steps? Step 1, rationalize the factor containing a square root and then simplify it. Your first step is what? Rationalize your function, whether nr contains a square root or dr contains a square root. Step 2, put the value of x after rationalization and then simplify and get the required result. These are the 3 steps which must be followed in a sequence to find out the solution of any question using method of rationalization. Let us take an example. For example, take this. Evaluate limit x tends to 0 root 1 plus x minus root 1 minus x divided by 2x. So what we will do first? First we will use the method of direct substitution, means put x is equals to 0 in the given function. This is what the method of direct substitution say, right? So if x is equals to 0, the given expression takes the form this. Look at this. If you will put x is equals to 0, what is left? Root 1 here minus root 1. So root 1 is 1, 1 minus 1 upon 0. So 0 upon 0 means the method of direct substitution fails, right? We cannot use the method of direct substitution. Second stage is what? Second method we have studied, that is method of factorization. Factorization method we cannot use because in case of factorization our NR or DR cannot contain square root. Here numerator contains square root. So method 2 already ruled out. Now naturally we will have to come at method 3, that is method of rationalization. So what we will do here, NR contains square root, so we will remove this square root from NR, right? And you know how square root is removal. We can remove the square root. Look at this. This is your function root 1 plus x minus root 1 minus x, right? This is your function enclosed in a bracket like this. So removal of a square root is being done. Here we are having minus sign in between these two. Use the plus sign. Multiply and divide the given expression by root 1 plus x plus root 1 minus x to remove the square root, right? Let us see. Limit x tends to 0, root 1 plus x minus root 1 minus x divided by 2x. This is the original function. We are multiplying and dividing what? Root 1 plus x plus root 1 plus x, this one. This is division and this is multiplication, right? Now, what is the case? You know the formula of a minus b and a plus b. This is equals to what? A square minus b square. Now, take this as a, take this as b. So, this is a minus b. So, a plus b. So, a minus b, a plus b becomes a square minus b square. So, what is its square? Root and root 1 plus x square is what? 1 plus x. So, what is left? We will left here 1 plus x minus 1 minus x. In dr, we will remain the same, no change. Simplify it. What is left? 1 plus x minus 1 plus x. So, what is left? 1 and 1 will be cancels out. It is left 2x divided by dr will remain the same, right? Now, see here 2x and 2x will be cancels out. What is left? Limit x tends to 0, 1 upon this your dr will remain as it is, that is root 1 plus x plus root 1 minus x. Again we will use the method of direct substitution, that is put x is equals to 0 to find out its limit. Substitute x is equals to 0 here, you will get 1 upon 2 as its limit, right? Now take the example 2 very quickly. Limit x tends to 3 x square minus 9 divided by x square plus 7 minus 4, right? So here dr contains square root. So what we will do? We will remove the square root from our denominator. By what? By look at this. This contains x square plus 7 and this 4 is outside the square root. So we will multiply and divide by this, right? See, put x is equals to 3, the expression takes the form 0 upon 0. Method of direct substitution fails, right? Now, limit x tends to 3, x square minus 9 divided by this. We are dividing and multiplying x square root x square plus 7 plus 4, this quantity, this, right? So, look at here, here NR will remain as it is, no change. Here the same thing, a plus b, a minus b, root x square plus 7 minus 4 first factor, root x square plus 7 plus 4 second factor, a minus b, this is a plus b. So, you will get here a square minus b square. Square of this is what? X square plus 7 and square of 4 is minus 16. What is left? X square minus 9, right? See, simplify this, you are getting x square minus 9. X square minus 9, this will be cancelled out. X square minus 9, x square minus 9 will be cancelled out. What is left? Limit x tends to 3, x square plus 7 plus 4. Again use the method of direct substitution to put x is equals to 3 and then simplify it. You will get 8 as the limit of the given function. So, what is the meaning of this? All the questions of rationalization method will be solved using the same approach. You will have to simply remove the square root if NR contains from NR and from DR if DR contains, right. Take this example also. Evaluate limit y tends to 0, y square minus 1 divided by 3y minus 2 minus y plus 2, right. Now, we will use the same technique, put y is equals to 0, use the method of direct substitution. What will happen? You are getting 0 upon 0 because 4 minus 4 divided by 6 minus 2, this is 4, 2 plus 2, this is 4, 4 minus 4, 0, you will get 0 upon 0. The method of direct substitution fails. Now, we cannot use the factorization method because dr contains a square root. So, only way out is what? We will use the method of rationalization, right. To rationalize this, here what we are having, root 3y minus 2 minus root y plus 2. This is our dr. So, from what we should multiply? We should multiply and divide by plus sign change. So, this is what we did here. Y square minus 4, you can see this can be written as y minus 2 and y plus 2 by the formula of a plus b, a minus b. So, this is y minus 2, this is y plus 2, this will remain as it is. Here in denominator you will get the same thing, the same formula of a minus b and a plus b, this is equals to a square minus b square. So, what we are having, root 3y minus 2, it's a square minus root y plus 2, it's a square. What you will get? 3y minus 2 minus y plus 2, and then simplify it. After simplification, you will get y minus 2, y plus 2, 3y minus 2 plus y plus 2. Y minus 2 and y minus 2 will be cancelled out. What is left? Y plus 2 and this portion, right? Y plus 2, 3y minus 2, this. Again, use the method of direct substitution to find out the required limit of the given function. Means put y is equals to 2 and then simplify it. So, see here, 2 plus 2 is 4, 3 into 2, 6 minus 2, this is 4, 2 plus 2, this is 4, root 4, this is 2, this is 2, 2 plus 2, 4, 4 into 4, 16 divided by 2, that is 8. So, this 8 is the required limit. So, this is all about the 4 methods which we can use to find out the limit of the various functions. Method 1, the method of direct substitution. Number 2, factorization method. And number 3, rationalization method, right. So, what is the basic difference? This we have also discussed. First, whenever a question comes before you, first try to find out its limit by the direct substitution. If you are getting a finite number, you are okay. If not, then you can use for other options. If the function is of the form of fx upon gx, then you can think of the factorization method and find out its limit. On the other hand, if the function is of the type of fx upon gx, but either nr or dr contains the square root, then we can use the method of rationalization method to find out the limit of the given function. I think this is all about the methods to find out the limit of the various function. So, thank you very much, students. We would like to stop it here, and in the next lecture we will study something more to find out the limit of the various kinds of functions. Thank you.